Hi, welcome to section 11.3 notes on surface area, pyramids, and cones. So what we're doing today is very similar to the section 11.2 notes in terms of finding surface area, but it's just of new figures, this time pyramids and cones instead of prisms and cylinders. But you're going to see a lot of similarities. The formulas are different, but the letters within the formulas mean the same thing as what we talked about in section 11.2. So I think this section will go a little more quickly because of how similar it is to section 11.2. So here we go. A pyramid is a polyhedron in which the base can be any polygon and the lateral faces are triangles that meet at a common vertex. So similar to a prism, that the base can be any shaped polygon. It can be a triangle, a square, a rectangle, a hexagon, a pentagon, any shaped polygon. The difference is that a prism has two parallel polygon bases and a pyramid just has one base. Again, a pyramid all comes up to one point. The triangles are the lateral faces where, again, because the prism has two bases, the lateral faces are all rectangles or squares if it's a cube. So again, some similarities, some differences. You can see in this picture to the right here that it's a hexagonal pyramid, and you can see the vertex is this point up at the top. You can see the lateral edges are kind of the straight edges of the triangles that make up those lateral faces. You can see the base edge is down here along the bottom, and you can see the next word that we have written here is called the altitude. And you can see the altitude in this case comes down through the middle of the pyramid and forms a right angle with the base. So the altitude, another word for that is the height, or H, is a perpendicular segment from the vertex to the plane of the base. A regular pyramid has a base that is a regular polygon and lateral faces that are congruent isosceles triangles. So we'll have that at times. And then the slant height is the length of the altitude or height of a lateral face of the pyramid. So big thing to keep in mind here is we already talked about the height or the altitude of the entire pyramid. It comes down from the vertex down through the pyramid and forms a right angle with the base. Okay, but a difference is a slant height comes down through one of the faces and forms a right angle with the base of just that face. And we're going to call that this lowercase cursive L. So again, there's a difference between the height and the slant height, so be really careful with which one you're using. If you know one and want to find the other, you can use Pythagorean theorem to switch in between because that makes a right triangle here in the middle. You can kind of see the height with this length from the center out to the edge, and then the slant height being the hypotenuse. You can use Pythagorean theorem to kind of find some of the missing pieces here. So next up is just kind of explaining the different parts of the formula. So it says the lateral area of a regular pyramid is half the product of the perimeter of the base and the slant height. So again, the 1/2 is new. The P stands for perimeter of the base, which, the P stands for the same thing as what we talked about in section 11.2. And the slant height is something new and for the pyramid. And again, we can see that in this picture. That comes from the vertex down through the face, lateral face, and forms a right angle at the base of that face. The surface area is the lateral area plus just capital B, not 2B, like we saw in section 11.2, just capital B because there's only one base. And don't forget that capital B stands for area of the base. We're not just taking one number from the figure and plugging it in for capital B. We're actually finding the area. So that's using any of those chapter 10 formulas to find capital B. All right, on number 1, it says find the exact surface area of a hexagonal pyramid. So in this particular case, we can use the formula that we just mentioned, we can say that the lateral area is equal to 1/2 the perimeter times the slant height. So if we look here, the perimeter, if it helps you to do some work off to the side, the perimeter is equal to n times s. We know that the number of sides, since it's a hexagon, is 6, and the length of one side, we can see right here, is 6. So the perimeter then is 36. The slant height, I can see they're specifically giving me. This is the slant height, which is 9. And if I multiply that out, I get 162 for the lateral area. All right, for the total surface area, the formula is the lateral area plus capital B, or area of the base. So we already know the lateral area is 162. To find capital B, I have to do some work to find the area of the base. I like to do that work off to the side. So I know that capital B is the same thing as the area of the hexagon. And the area of the hexagon, I can use the formula 1/2 apothem times perimeter. So in this case, my apothem, I can tell they're giving me that in the picture. The apothem of the hexagon is 3 square root of 3. And the perimeter of the hexagon we already found right here is 36. And to get that simplified down, we can say 0.5 times 3 times 36, and that gives me 54 square root of 3. Again, I want to keep it exact as I work throughout the problem. I don't want to round and round throughout the problem and really throw off my answer. So down here I have plus 54 square root of 3. And if they ask me for the surface area in exact form, that would be my answer, because the directions... Oh, this one does say find the exact surface area of the hexagonal pyramid. So technically, the exact is what I have right here, and I would put inches squared. Okay, if they did ask me for the approximate, then I would actually put that in my calculator, round to the nearest tenth, and get 255.5 inches squared. Okay, so just be careful what it's asking for. Sometimes with the notes, I like to show you both just to make sure you understand how to do both ways. All right, if we look at example 2, it says find the lateral area and surface areas rounded to the nearest tenth. So in this particular case, same idea, lateral area is 1/2 perimeter times slant height. The perimeter, I can tell it's going to be a square, and so I know the perimeter is equal to n times s, which is 4 sides times 30 for each side, which is 120. And the slant height, if I look here, the slant height goes from here to here, and they did not give me that length. I'll put an L in the picture. But I can see a right triangle is formed here. I can see the actual height is 36.4. And try to think about what you think this length is from here to here. You should be able to figure out with what is given to you. If we know that it's 30 from here to here, and we know C is at the center of the pyramid, then we know CA has to be a length of 15. So I can use Pythagorean theorem here. And I can say 36.4 squared plus 30 squared is equal to L squared. Oh, I didn't actually. Just a second. I did not mean to write 30. Didn't look at my picture. So I meant to say 15 squared is equal to L squared. Right, so if I go ahead and work that out, if I go ahead and do 36.4 squared plus 15 squared, I get 1549 0.96 is equal to L squared. And if I go ahead and take the square root of both sides, I'm just going to leave it for now as the slant height is equal to square root of 1549.96, just again to keep it exact throughout the problem. So when I go to plug the slant height in right here, I'm going to leave it as square root of 1549.96. Okay, if it wants me to find the lateral area, I can now plug that in my calculator and round to the nearest tenth, and I get 2362.2 meters squared, and that's my lateral area. Okay, to get my total surface area, it's going to be my lateral area plus capital B. Okay, so in this case, you may want to just keep it exact for now, just so I'm not rounding too much throughout the problem. I've got 60 square root of 1549.96. Or if you already have that 2362.2 in your calculator with other numbers following it, if you have all that left in your calculator, that is the exact part of that. So you could just use that. And then plus area of the base. If I come up here, I can see area of the base. The base is a square. And so I'm just saying 30 times 30, which is 900. Okay. And from there, if I go ahead and combine those together, rounded to the nearest tenth, I get 3262.2. Okay, so moving right along. On example 3, says find the lateral area and surface area of the pyramid. If you're getting the idea, you're welcome to go ahead and try this one, and then you can just check back to see if you did it right. I'll go ahead and work it out for now, but it's a good idea to get to practice. So I've got 1/2 PL for the lateral area. We've got a pyramid again. In this particular case, I can see that the perimeter is the 4 sides. So that's square base times one side, which is 5, and that gives me 20 for the perimeter of the base, and the slant height is 6. And if I go ahead and multiply that out, I get 60 meters squared. So that's the lateral area. Now for the surface area, I have the lateral area plus capital B. So in this case, I've got 60 plus the area of the base. Base is a square, so that's 5 times 5, which is 25. And if I go and add those, I get 85 meters squared. All right, so that is your surface area of that pyramid. All right, let's move on to the cones. Kind of like section 11.2, where the prisms are a little more challenging because the bases can be different shapes, and the cylinders are pretty straightforward and easy. Kind of the same thing with the pyramids and the cones, since the base of a cone is always going to be a circle. So here for a cone, it says a solid that has one circle base and a vertex that is not in the same plane as the base. The altitude or height is a perpendicular segment from the vertex to the center of the base. And the slant height, or the L, is the distance from the vertex to a point on the edge of the base. And we can see the picture over here. You know, vertex is the point up here. Slant height is the slanted part of the cone. The actual height or altitude comes down through the middle of the cone and forms a right angle with the base. The radius right here goes from the center out to the edge of the circle. You can see the height that goes to the middle and the radius and the slant height form a right triangle. So you can use Pythagorean theorem to switch between them. So on section 11.4, again, the formula here, they're kind of showing you the general formula, but I like to use this more specific one for the cone, that the lateral area is equal to pi RL. They're kind of showing you where that comes from, but that's kind of the most simplified version. And then the surface area is just taking that lateral area and adding capital B to it, which is the area of the base, but the base is always a circle. So technically for the surface area of a cone, we have pi RL plus pi R squared. All right, so on example 4, if we go ahead and find the exact surface area, leaving it in terms of pi, then if I want to go and find the lateral area first, that's fine. And that formula is pi RL. So in this case, I can see that the radius is 15, and I can see the slant height is 25. And if I go ahead and multiply that out, I get 375 pi. All right, if I now want to find the surface area, I know that I have the lateral area plus capital B, but the base is always a circle, so I know I'm actually using pi R squared. So I've got 375 pi plus pi times the radius, which is 15. It's not very good. Let me try that again. Trying one more time. Okay, so I've got 375 pi plus pi R squared. And if I go ahead and get that simplified down, now I can combine those together because they are like terms. They both have a pi. So if I combine them together, I get 600 pi centimeter squared. All right. And again, they said leave it in terms of pi, so I don't want to multiply through by pi in this case. On example 5, they want the exact surface area for the following and to leave in terms of pi. So a couple things here that you want to be careful of. I'm going to start off the same way that we've got pi RL. So be careful on this one, the fact that if they're showing you this line all the way across, we know that's the diameter. So I know the radius is half that, which is 2. So make sure you're plugging 2 in for the radius, not 4. Slant height, they did not give me this time. They gave me the actual height that's coming down to the middle. I can see it forms a right angle. So I need to figure out what this slant height is. Also, I need to make sure I realize that if it goes 4 all the way across to the diameter, then I know the radius is 2. Okay, so I can use the Pythagorean theorem to find the missing pieces here. So I can see the slant height is my hypotenuse. So my actual height is 5. The other leg of the right triangle is 2. And I don't know what the slant height is. So if I go ahead and solve for that, I get 25 plus 4 is equal to L squared. So 29 is equal to L squared. And if I take the square root of both sides, I get square root of 29. And that's what goes in for the slant height. If I go ahead and get that simplified down a little bit, then I've got 2 square root of 29 pi feet squared. All right, from there, if I go ahead and figure out what the actual surface area is, I know that it is the lateral area plus capital B, but the area of the base is always a circle, so technically I'm doing plus pi r squared. So 2 square root of 29 pi plus pi radius, we already said was 2, and then we need to square that. So I've got 2 square root of 29 pi plus 4 pi. And because it says find the exact surface area and leave in terms of pi, then I'm leaving my answer like that. Okay, I can't combine the pi's together because one has a square root and one doesn't. So do not say 6 square root of 29 pi. Can't do that. So you're just going to have to leave it separate since one has a square root and one does not. Okay, so be careful with that. All right, that's it for section 11.3. Just let me know if you need any help or have any questions.